Okay, so here's the question. I'm given this matrix A, and I want to find its inverse. Here is a procedure that will do the job. We're going to create an augmented matrix with two blocks. The left block will be the matrix A. The right block will be the identity matrix of same dimensions as A. So let me copy A. Here I will have A, negative 1, 0, 1, 0, 1, 1, 2, 0, negative 1. Here I will have the 3 by 3 identity matrix. 1, 0, 0. 0, 1, 0, 0, 0, 1. Okay, so here's the procedure that we need to go through. We need to reduce this matrix into reduced row echelon form via elementary row operations. Now, we start as follows. Go to your first row. The first non-zero entry should be in the first row, first column of that matrix. Make it a 1. Right now, that requires I multiply the first row by negative 1. So apply that elementary row operation. Negative 1 times the first row of the augmented matrix. Okay, so here's what you obtain. That's going to be 1, 0, negative 1, negative 1, 0, 0. Everything else remains unchanged. So 0, 1, 1, 0, 1, 0, 2, 0, negative 1, 0, 0, 1. Okay, next, you will go to that first non-zero entry in the first row. That's going to be our pivot. That's called a pivot. We're going to utilize that non-zero entry to eliminate every other non-zero entry in that column. So in this case, all I have to do is eliminate that too. How? Take row 3 minus 2 row 1. So row 3 minus 2 row 1. Okay, so 2 minus 2 is 0. Mission accomplished. You wanted to make that a 0? Mission accomplished. 0 minus 2 times 0 is still 0. Negative 1 minus 2 times negative 1 is negative 1 plus 2. Negative 1 plus 2 is 1. 0 minus 2 times negative 1 is 0 plus 2, which is 2. 0 minus 2 times 0 is 0. 1 minus 2 times 0 is 1. Everything else remains unchanged. So that's 0, 1, 1, 0, 1, 0, 1, 0, negative 1, negative 1, 0, 0. Okay, next, once you've done using the first pivot to eliminate every other non-zero entry in that column, you go to the next row. The first non-zero entry of that row, you will make it a 1. In this case, it is already a 1. Next, you will utilize that new pivot to eliminate every other non-zero entry in the column of that pivot. In this case, that's already done. there is a 0 there, and there is a 0 there. So they're already eliminated. So then move on to the next row. The first non-zero entry of that next row, make it a 1. It is already a 1. So use that new pivot to eliminate every other non-zero entry in that column. So you want to eliminate those two non-zero entries by using that non-zero entry. Okay, let's get rid of the -1 first. How? Take row 1 plus row 3 to replace row 1. So here we're going to take row 1 plus row 3 to replace row 1. So 1 plus 0 is 1. 0 plus 0 is 0. -1 plus 1 is 0. Mission accomplished. That's what we wanted. -1 plus 2 is 1. 0 plus 0 is 0. 0 plus 1 is 1. Everything else remains unchanged. So 0, 1, 1, 0, 1, 0, 0, 0, 1, 2, 0, 1. Okay, now we have to eliminate the other non-zero entry that remains to be eliminated, which is the 1. So in this case, I'm going to have to take row 2 minus row 3 to replace row 2. So row 2 minus row 3 to replace row 2. Okay, so 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. Mission accomplished. That's what we wanted. 0 minus 2 is -2. 1 minus 0 is 1. 0 minus 1 is -1. Everything else remains unchanged. So that's 0, 0, 1, 2, 0, 1, 1, 0, 0, 1, 0, 1. Okay, so we are done. We started with the augmented matrix consisting of two blocks, A in the identity with same dimensions as A. We applied elementary row operations until we arrived at a reduced row echelon form matrix. So what's the significance of what we obtained? First, we confirmed that A is row equivalent to the identity. So we just confirmed that A, in fact, is invariable. But we also obtained something else. We obtained this block right here. That happens to be the inverse of A. That's the method that we are using to find the inverse of A. We begin with the augmented matrix consisting of A on the left block and the identity on the right block. We apply a sequence of elementary row operations up until we obtain the reduced row echelon form matrix that has the identity on the left block and has the inverse of A on the right block. Okay, confirmation. Did we actually get the correct answer? Of course, the answer is affirmative. That was the inverse of A. Okay, we're going to try another example, a bit simpler.